Lawsuit's still open.
Tom, it's not January.
Admin.
Oh, it's way late. Well, we're done. This finishes January. Tom, can we get, like they do at the baseball stadium, those cutouts of people just in there?
Put one for recordings. Today we're going to cover fire suppression systems and their use for my Instructor 2 project. And start off with the introduction. My name is Tom Hagemeyer. I'm a husband. A little bit about myself is I'm a husband and father of 2. I worked with Clayton Fire Department for 9 years. Obtained my Bachelor's of Science in Nursing in 2007 and attended the Fire Academy right after graduation back in 2007 and started my career working in an emergency room. I worked for 5 years full-time and then 5 years part-time after I became hired with the Clayton Fire Department. And I'm a student of the fire service. So I wanted to include that in there because it's, you know, 2 of the things I'm currently most involved in and most proud of is being a husband, father, and then you know, continuing to be a student of the fire service. I think it's important to prioritize learning and education in this job because there's a lot to know and there's a lot to do, and we have to constantly work at being the best we can. High-rise incidents are very challenging. You know, they place a high demand on personnel and resources. When these fires occur, you know, they happen in very remote locations, high up in buildings, and very difficult to get resources and personnel to meet the demands where they need to go. I'm going to talk a little bit about NFPA and some codes. It's not a code class, but I'm going to have to reference the codes and NFPA. They provide a lot of answers and a lot of guidance on how we use and operate these systems. But NFPA 1710 says we should get 43 firefighters on scene at a high-rise fire within the first 10 minutes. This does, you know, not to mention reflex time. So reflex time is a factor where the first fire attack engine arrives on scene, they hit their air brake, the timer starts from the time they can assemble a hose line and make a fire attack in a high-rise building. So depending on what you read, this time could be anywhere from 10 to 20 minutes, more realistically from 15 to 20 minutes before the first line gets in place to make a fire attack at a high-rise fire. Normal tasks on any fire are not easily accomplished in a high-rise fire, just due to the layout, the construction, and the remote location of the fire. Ventilation, we can't take out windows in high-rises most times. Horizontal ventilation will be very difficult, and our opportunities to vent vertically are going to be very limited. So that's going to be a challenge. Fire suppression. Dave McGrail is a huge instructor on high-rise fires. He likes to call it positive control. So we use our fire apparatus. We're hooked to it. That's our lifeline. It's all equipment that we've checked. He likes to call that positive control. We put a lot of faith and trust in these systems, so we should know how they work. So hooking up to a standpipe, we lose that positive control. So through good pre-planning, good understanding, and good trainings and how we operate on these systems, we can put the best step forward in using these systems and mounting a successful attack. Water supply. Like I said, we've lost that positive control. Many of these buildings have fire pumps, and we will allow these buildings to work until they don't. When they don't, you know, there's an FTC which we can provide the water to the building for fire suppression. But we're gonna get into that. That's a whole other topic. Access and egress, very limited. We got stairs and elevators. Elevators can become compromised very quickly. And then there's multiple building systems. Like we said, there's stairwells, pressurized stairwells, HVAC controls and how they operate in fire alarm systems and water suppression systems. So these aren't our typical fires. We have a lot of exposure to these buildings and getting in there. So it's become a lot more fundamental and routine for us. So we may take that for granted, but there's a lot of knowledge in this room, and there's a lot of experience with these buildings in this room. We may take that for granted, but when people come into our city, and if we have an incident that's a significant high-rise fire, they're going to look to us for the answers and guidance. So, and again, these incidents are high risk, low frequency, and you know, it's important to drill on these. So this is much more fundamental for us. We interact with these systems on a day-to-day basis. We see these calls. We have to go problem solve these buildings. So there's still high risk, low frequency of a significant high-rise fire. So it's important that we, you know, stay diligent in our education, our training in these buildings. Knowledge, skills, and ability. I want to kind of just go over, like I said, I'm a student of the fire service. I think it's really important that we remain disciplined and don't become complacent in what we know. Just because we don't apply some of this knowledge every day doesn't mean it's not going to help us along the way in these incidents. So knowledge can be, you know, the information gained from learning and studying, things we remember. Skills, that comes through drilling and training. It can be kind of difficult to create realistic high-rise training. You know, it is a goal of mine going forward that we can put some training into use where setting up a relay system or a series pumping system is more routine to us because we've done it in training. And, you know, high-rise ops. You know, we don't have a training tower, but we can get creative and put together some good training so that we recall back on that muscle memory. And then ability. It's just you take what you've learned, take your education and what you've drilled on, and be able to apply that when the situation arises. And again, high risk, low frequency, experience is crucial. It's kind of hard to gain experience in high-rise fires when it is a high-risk, low-frequency event. So, you know, our experience can come from good, deliberate training and calling upon those who have interacted with the systems, our senior members and our officers who have interacted with these systems and know their use, and, you know, constantly hearing from them sometimes that when we've hooked up on these systems, sometimes we've had extremely low pressures, or, you know, it didn't react how we thought it would, or we broke an FDC because it was a remote FDC. We're going to talk more about that, but basically, we need to lean on, we need to hear the stories from the guys who have done it before us. So, knowledge learned only gets you so far. The practical review and practice hands-on training is needed and crucial for these incidents. Can't wait around on experience, especially in high-rise fires, like I said, and listen to those who have done it or who are doing it and providing those trainings on a national level. That's important. And then you don't know what you don't know. And we all can be guilty of this, but that's why I think it's important to reach out to the guys who teach on any subject, but especially high-rise fires. You know, Dave McGrail, Bill Gustin. There's a lot of webcasts and information that come out from guys who fight fires in really tall buildings, and they've been around the block, they've done it, and so, you know, I've enjoyed learning from them. But we don't know what we don't know, so if you have questions, they may have the answer. So I had questions on how I can be a better firefighter and perform my job in a high-rise fire. So that's why I want to put this class together. Went out, just did as much studying as I could, and I picked some things up, and I wanted it to be, shared with the team. And then the Marines. I want to talk about the Marines, their approach to things. So when we think about Marines, very structured, they may follow protocol, march to their death. That's actually not how Marines are taught. They prioritize and value highly creativity and ingenuity, and that allows them to be creative and adapt in incidents where there's many variables, high stress and critical incidents. So that's what we need to do, and they do that through a culture of learning. They really prioritize learning, creativity, and ingenuity in the field, and that's done through learning and education. So, heard things from members like common sense is gone, and many things in this job can be condition dependent. So we're only going to get better at our ability to adapt to these condition dependent experiences, but we're going to do that through hands-on training and education. So they go hand in hand. You can't just read books and think you're going to get everything you need to know. You need to practice, drill, train, and be disciplined on having a true understanding of these systems, so that when a problem arises, you make the correct decision in a timely manner. Our interactions with the systems are frequent, but like we talked about, the fires vary and are very infrequent. So hopefully this training will help provide more knowledge and a foundation of knowledge of these systems, and will help us to be successful in our everyday operation in high-risk, low-frequency environments. And then recognition, prime decision-making, that's all that is. The ability to recall what you've done in the past. You kind of go back on your mental Rolodex of experiences you've had, decisions you've made, and a successful outcome. So we hope that
Assistant Blood, Subcutting South Henley Road, 3217 response. For assistant and Blood, Subcutting South Henley Road, Crush Street, Davis Drive, apartment 68. No criteria complaints, 3217 responding, East Central Maine, about 239.
Yeah, so, being a student, learn about different things. This is huge. This is huge. Just this concept, we all know, you train till you can't do it wrong. Don't train until you get it right. Train until you can't do it wrong. That's kind of what this is. You train, you learn. As we gain experience, we go back on that mental Rolodex of decisions we've made and the successes we've had, and that's what we're going to do when we're operating in a high stress environment. So we hope that what we're drawing back on is the correct protocol or the correct steps that led to a success, not an accidental success. So that's why I kind of harp on training and knowing the most I can about this job. But you don't rise to the occasion, you fall back to your level of training is another way to put it. And we can do this through focusing on our fundamentals. So high-rise stuff may not be fundamental for other departments, but for us, stretching off a standpipe, the building components, operating elevators, those are our fundamentals. We do those much more than other departments, so focusing on those fundamentals, breaking them down to tasks, and allowing them to become second nature because we've practiced and trained on them is an important way that we can use RPDM to be successful. And then removing the variables. So, listen to the guys who've been there and done it. Any plan you have, there may be critical factors involved in using these systems are making decisions. But if you can keep any plan simple and remove variables when you can, you're going to be better off in the long run. It's going to be easy to operate under those conditions and follow a plan when you can remove variables and keep the plan simple. So that's very important. So I may talk about later, some math problems with setting up a series pumping procedure are, parts of the building that are a little more complex. But if we try to keep the plan as simple as possible and streamline things, then it's going to be easier for us to operate and capture success. Any questions so far? Kind of haven't even gotten into high-rise stuff, but I think it's important to understand, when we're training, when we're learning, those things we've talked about. Yeah.
So the NFPA standard for having 43 personnel within the first 10 minutes, is that from the first 10 minutes when you get the alarm, or from confirmed working high-rise fire?
I imagine it's probably from a working high-rise fire.
Okay.
And that's what they say, that's what NFPA recommends, so each jurisdiction might do that differently. Here in Clayton, I think we've learned not to go straight to the third alarm once we know there's a working high-rise fire. We'll strike the second, and then we'll strike the third, so that the second alarm assignments aren't skipped over. But that's one of the reasons that's being done, I think, to meet that NFPA recommendation. Would you agree there? Yeah, so striking a second alarm and then pausing, or saying striking a second alarm and a third alarm. Our learning objectives, kind of paraphrase through these because it's a lot of words, but I'm going to provide a worksheet a little bit later and a little quiz at the end just to kind of help reaffirm what the key points of this are. But we're going to identify and match critical pieces of a high-rise suppression system with their function. And we'll use a worksheet to match the type of standpipe valve to how they work and the method to overcome their actions and pressure reduction. And then calculate pressures in a series pumping procedure that will provide the appropriate pressure for the building using a series pumping operation. And then, given the conditions of riser failure, we're going to list the 4 components needed to construct an exterior vertical standpipe in a scenario of riser failure. So it's important. We're going to go over the pump room components as well. Depending on where a failure occurs in the system, it's going to dictate what's going to take to get water where we need it. So we're going to get to that. And then fire suppression systems in the pump room, we're going to be able to accurately identify these components and the method needed to provide effective water in the event of a failure. Now, multiple problems occur in these systems when there is no fire. We've seen that. And when there is a fire, we must know the components of the fire suppression system, their functions, and how we use them. In doing so, we'll identify our backup plans in case of system failure, such as catastrophic leaks or breaks in the system, a non-functioning fire pump, or other problems that interfere with fire suppression. We'll also discuss the importance of setting up a series pumping procedure when we're pumping into an FDC and how to safely do that. Our outline, we're going to cover sprinklers, standpipes, pressure reducing valves or devices, the fire pump room, the FDC, and then a series pumping operation and plan B. So kind of used a top-down approach. It organized itself in my head like that, and it makes sense. So one challenge with fire service and fire departments is there's a vast change. There's a lot of difference in responsibilities and experience from one member to the next. And so as we go down, you can see it's good review and good knowledge for everyone to know. But as we start going down, it gets a little more complicated. And as we get down here, this may be, the more hands-on application for our drivers and then our officers and even incident command down here. But it's good knowledge for everybody. I've studied this subject for quite some time and you know, learned a lot. And I just want that to be shared and for this to be a good resource for people. So, you know, if you're newer and we get down here and start talking about a lot of stuff, you may not understand immediately, that's okay. So we all pick up little bits and pieces and continue to build upon our knowledge, but just know that's how it's going to go, kind of introductory, intermediate, and then, you know, some advanced application at the bottom. Yeah, so that's what this says too. The level of instruction, you know, basic, good for everybody, is knowledge on sprinklers, PRVs, standpipes in the fire pump room, and then intermediate, series pumping procedures, the FDC, and what to do when things go wrong. So I put these. We're going to get into this later when we talk about series pumping, but I put these two pictures up here because they're super important when we're talking about pumping. And this is just a picture of our intake gauge and discharge gauge on our pressure governor, and the pump data plate up there. So the relationship between residual pressure and discharge pressure and net pump discharge pressure is important. You know, NFPA recommends when we're setting up these relay systems to keep the capacity of your pump. So we're going to get into it, but as you can see here, we have a 1,500 gallons per minute pump, 150 psi pressure that we create at 1388 RPM. So as we create more pressure, 200 or 250, you can see our capacity goes down. So we're going to get into that and why that's important, but it's recommended that when we're setting up these systems to keep the capacity of the pump. So kind of wanted to throw these pictures in there. Sprinklers, the NFPA standards that are applicable to sprinklers are NFPA 25, 13, 13E, and 13R, which we're not going to dive deep into, but those are the ones if you want a little light reading. Sprinkler versus non-sprinkler obviously plays a huge role in how we operate in these buildings. In high-rises, it's now mandatory for high-rises to be sprinklered, and many of our buildings are being retrofitted with sprinklers. And just to have a general understanding that there is many code variances in buildings that they are sprinklered or non-sprinklered, such as the fire resistance ratings of materials, how long, you know, a stairwell, a safe stairwell may be rated for when exposed to fire. All depending on if a building has sprinklers or not. Distance to travel exit to the furthest point. We ran a call at one of our buildings today that has a very long distance from where the standpipe is to the furthest point we need to get in that building. We know we're going to need over 200 feet of hose in the crescent, right? So that was one building that was allowed to be a little outside the code, I believe. But it was allowed. It's a sprinkler building, and we just need to know our buildings. But in general, if it's a sprinkler building, the travel exit to the furthest point is 200 feet, and a non-sprinkler 130 feet. So if you think how we attach on a standpipe system, 200 feet of hose, it's 50 to come up from the floor below the fire, then we operate with 150 feet. So that's a straight line. So if we're going around office equip, you know, office supplies or different layout, we need to be able to adapt and extend our line if we need to. And then in this picture is kind of a drawing of a sprinkler head. The way they operate, I think we all know, is a frangible bulb. It's a glass bulb, and inside is liquid. As it heats up, it breaks and allows air and water to discharge through the system. And they're color coded depending on when they activate. There's 4 major classes of sprinklers. Wet. This will be water under pressure at all times, and they're activated by that frangible bulb when it breaks. dry. These are in areas that are subject to freezing. We commonly run calls on these. You know, when it freezes and it thaws, they break. So these can be filled with air or nitrogen under pressure, and again are activated by frangible bulbs when they break. The nitrogen is being used now because when just regular air is pumped into these systems and the presence of water and other debris, the corrosion goes crazy. So I believe the nitrogen keeps the corrosion down in the pipes. We have that in some of our buildings, and it's going to be more and more common. Pre-action systems. Again, there's air in the piping. It may or may not be under pressure, and a supplementary fire detecting device in the protected area is actuated. It opens the valve and allows water to flow into the pipe, and then the frangible bulb is activated by heat and allows the water to come out. So 2 different ways to get the water out. 2 different detecting mechanisms there to get the water out. And then a deluge. These are a deluge system. These are present in areas of high hazards or flammable materials such as industrial or storage facilities. And then this is what a deluge sprinkler head looks like. You can see there's a lot of water coming through there and it's just deflected. But those have no frangible bulbs. They'll detect heat or fire, and they are all open. They'll all flood the system and the materials present in that area. System design. Hydraulically designed with only a certain amount of heads. So heads activated. That's important to us because these buildings have a certain capacity. So if a fire were to grow and overwhelm a sprinkler system for whatever reason, at a certain point, more and more sprinklers are going to open up, but the system will not be able to keep up with that. So in residential, the system can be designed as low as 4 heads, but in commercial, it can be up to 50. So that's a significant area. When sprinklers operate how they're supposed to, they're like 99% effective. Yes.
Are both residential and commercial buildings designed for fire suppression or for life safety?
Both. I mean, it depends, right? That's what you're asking. So,
has a residential sprinkler system put out as much water? You said it's only 4 heads, but it won't. Is it more designed for evacuation or to put out the fire?
More for life safety, and we're going to get into actually how they work, but sprinklers many times will not put out your fire. It'll manage the fire and keep it smaller by cooling gas temps at the ceiling and also pre-wetting materials around it. So it may not put out the fire. It may not reach the fire and put it out, but it's going to cause a lot of smoke. It's going to pre-wet the materials around it and help slow the burning process till we get there. So, I believe we just had a sprinkler-controlled cold smoke fire in Clayton, and it produces a lot of CO and a lot of smoke, and that smoke can travel throughout the buildings. So even though the fire may not be a huge threat, the smoke could be if it goes on for some time. So, but they help us. They help us out. And sprinklers are designed to achieve a density of water based on the hazard classification. So that would be in gallons per minute per square feet. So that's going to depend on what the occupancy type is or what the fuel loads are there. And then 12 to 15 foot spacing in general is how far apart your heads are. Like I said, sprinklers work by pre-wetting of exposed contents and is essential to their operation. And the ability of water to penetrate material is key to their effectiveness. So if you think about office equipment, it's just a lot of plastic, a lot of hard surfaces. Yeah, they're going to get wet, but that may not prevent them from heating up, off-gassing, and then burning. So Well, they are effective. They have their limits, and you know, many techs and many people who teach this on a national level say, you know, we grossly underestimate the fuel loads in an office building.
Attention all units, be advised, the East Central phone lines will be down until further notice. Attention all units of fire dispatch, East Central phone lines will be down until further notice.
We need to pause for anything. Yeah, what I was saying was many techs and people who teach on high-rise fires estimate that the fuel loads in office buildings are underestimated in the amount of heat fire they can produce. ESFR is early suppression fast response sprinklers. So these are special sprinklers in areas of high hazard. They require special piping, and they can put out a lot more water faster than normal sprinklers. I just want to include that because they're different. So if there is, you know, if the code calls for it, you know, we may encounter these types of systems, but they generally put out more water and they require special piping beyond normal piping for sprinklers. And those work by dumping water directly onto the fire compared to cooling, sealing temps, and pre-wetting the surrounding materials. This picture here is just an example of how much corrosion can build up in dry systems. I wouldn't trust dry systems too much. There's a lot of variables. We talked about, you know, removing variables when you can. So in dry systems, they're filled and charged with air. Every time they become charged with water, the debris moves, it introduces microbes in there, and it grows like that over time. So you may not get the flow you expect out of there. It may be clogged, there may be open valves. There's a lot of variables that just exist with dry systems. But so other sprinkler considerations are the FDC. You know, some buildings may have a fire pump, some may not. And do we hit that, you know, primary or secondary? Let the building work, or hit it early. So one method of thinking is that we talked about the capacity of these buildings can be limited with the fire pump that's there. Early increased support through an FDC can provide a greater volume to the seat of the fire at an early time if the FDC is supplied with the correct pressure. So some people may opt to take control of a building faster than other jurisdictions. That's just a command decision and condition dependent, another thing. And those conditions would be the extent of the fire. What we see on our arrival, what investigation says, and then what conditions dictate safe over pumping. We're going to talk about this again about, you know, we'll talk about that a little bit later. And then visible fire from the street, you know, you may want to, sometimes that's the command decision to take control of the building. It's a sprinkler building, but we have flames shooting out multiple windows on the floor. You know, those sprinklers are not being effective in suppressing the fire. Maybe they're holding it back, but you know, some people have argued that, and it is shown that early supply of an FDC can provide more water through the sprinkler system than a building's pump. Codes dictate that change in occupancy are not approved unless a sprinkler system meets or exceeds the occupancy hazard. So these are code enforcements, and you know, take from that what you will, but that may be followed. Sometimes that may be overlooked. As if an occupancy changes or the fuel loads change, are those sprinklers designed to keep up with that? Post indicator valves, these control the flow from the municipal supply to the fire suppression system. So when closed, you know, the fire suppression system will not have water. Alarm panel, this should give us vital information on what valves are open or closed. So if you know, command gets on scene, they look at the panel, or the company officer sees that, I mean, those are gonna be key things to know, that there's fire on the 3rd floor, but, you know, there's closed valves on the 4th floor, the 3rd floor. They're gonna need to be addressed and investigated. And then activated dry systems. It was suggested, I just learned this, I mean, you can see the corrosion that can build up. It was suggested of keeping a log every time a dry system becomes charged. You're more prone to have problems with corrosion. So if a system's always activating, just know that's going to be a problem building if there's a fire in a dry system area. Any questions so far? Sprinkler operations. So it's important to know the location of riser controls and ensure that they're open, like we said, which should be listed on the alarm panel as you have a closed valve. And then the tools needed to address these problems. So if we look at these pictures here, we have our riser here with a butterfly valve, a hand wheel, and this one is secure with the anti-tamper plastic, you know, tie, easily broken. This one, padlock and a chain. So when we're pre-planning these buildings, we can ask the buildings to either, you know, to change these, or we can just pre-plan ahead and know we may need some bolt cutters or have the correct tools to break this if we need to shut it. Only thing you want to be careful is that if you're breaking it with Halligan or striking tools, is that we don't want to damage the valve or the handle. I think that's how handles get broken a lot, is when we're messing with pressure restricting devices, trying to break those off, we can break the handle. Other things we see in this picture are this placard. These should be available, and they'll tell you more about the system if you stop, take a minute and read it. Here's a inspection or testing tag, and this is electronic monitoring switch. So that's what sends the signal to the alarm system. So if we were to have an activated sprinkler, it's important for us to know where these floor or zone controls are. Many times they're going to be in a stairwell, one of our stairwells, or in older buildings, maybe outside the stairwell in the ceiling, which our Fire Prevention Bureau has done a good job of making sure those are all labeled so we can get up in the ceiling and shut those off. But if we have an activated sprinkler, we send the new guy up to shut that water off, right? But we can shut the zone down, and there may be multiple zones. There may be multiple valves you have to shut. But in general, you shut the zone down, and the inspector test main drain will help drain the system properly and not through the sprinkler head. So if we're shutting this down, we want to make sure we open that test drain. That should drain everything from the zone into a drain pipe rather than waiting for it all to come out onto the fire floor. Yeah, and that's what we just covered. So any questions about that? Standpipe risers and valves. The applicable NFPA standards are 14 and 13E. NFPA 14 is the standard for the installation of standpipes and hose systems, and 13E is probably the most important for us to be familiar with. If you have to read through the code, sometimes it can not be the most exciting material or easy to read, but 13E is the recommendation in practice for fire department operations and properties protected by sprinklers and standpipe systems. So a lot of the questions I have were answered by that NFPA 13E. And a lot of the things I reference in there, it gives you the answers. So if you have questions, that's a good place to start. These standpipe systems can be combination or separate, meaning that, like in this last picture, the standpipe hookup and the sprinkler control valves come off one pipe. That's a combination system, you know. You hook into one FTC and it supplies both. Or they can be separate like this. And hopefully they're labeled right. You know, when we're doing inspections, it's good to know our buildings and double check these and make sure that they're labeled correctly. But you know, this one will be automatic sprinklers. You're going to want to hit that first if there's a fire. That way, you know, if there's, you know, the pump's down or it needs extra support, you can provide that initially. Because like we said, there's reflex time. We may have additional time to hook up to this one, the standpipe, 15 to 20 minutes or 10 to 20 minutes before we have to hook up to that one. But some jurisdictions will color code these for easy identification. You know, this one has been green for sprinkler and yellow for standpipe. But in general, if you have this, you're going to want to hit your first line into the sprinkler system first. Risers, the design of the standpipe system and the risers are based upon building height, the area per floor, occupancy class, the amount of fuel loads or what the occupancy is, egress system design, the required flow rate and residual pressure of the building that's available, and the distance of the hose connection from the source of the water supply. So this can affect how many risers there needs to be in a building, which will let us know, you know, additional hose connections on the floor. So there could be a number of risers or a number of additional hose cabinets on the floor to meet the code. I didn't get into fire control systems such as compartmentalization or fire doors, but you know, I believe in the modern code, if there's hose cabinets on the fire floor, these are protected with fire doors. So when we're doing our inspections or walkthrough, it's important to make sure that those close so we can use those hose cabinets. So that we're protected while we're hooking up. Any questions? I think why don't we take a little 10-minute break? We're going out for 40 minutes, so we'll take a little break, 10-minute break, and then come back in here. Thank you.
Hey Tommy,
Yeah.
I learned something. I never had heard of NFPA 13E.
So,
It's cool. So you can open that up and it will go through what you're supposed to be training on and the system.
absolutely, and it's written in firefighter language. It's, you know, all these, I believe all these NFPA panels have firefighters on them, chiefs on them, and then engineers. So this one seems to be very much designed and written based on the experiences, the problems, the code changes, which we're going to talk about some of the significant fires that have happened to change the codes. It doesn't do a lot of reference in different codes. It says, hey, you should set up, we're going to get into it, so I'll repeat myself, but it says you should set up a series pumping operation whenever the system demand is over 150. So for every 150, so if it's 450 PSI system demand, you have 3 pumpers or a 2-stage, 3-stage high pumping apparatus. So there's a lot of questions that have been answered just by reading it.
So look it up. Never knew it existed.
Any more questions? Lay down. More questions. All good. Questions?
We pause the leave it going.
I gave Ted some on that building. You don't have them. Test results for pressure reading now to see the pressure coming in and the pressure going out. Another fire pump acceptor set.
Yeah.
So you better see what the fire pressure you were coming out of it. Because one of the you're going to be there forever. you know, they feel that, it's the first thing that, for the parking garage. Yeah, it's all automatic drive. Typically on the way, the other one's on the way, you know, there's a question, maybe it's a little something, if you get somebody, they feel, so you're like,
That way, that's very, yeah, you got straight back, you're gonna be going out and make a price of them.
Right.
In that particular situation,
I think they're like
high-rise built.
$1 a pound.
The high-rise built, which it is, not a separate parking garage.
Yeah, I figured that way.
Then it would be a place.
Yeah, that's what I got. So, it's up to the doctor. So, when she gets there,
So it's a high-rise. They have to have.
doctors are available for your doctor.
I think those three guys.
Basically, said you want to say, the outfit,
This is what.
sure when you're
Because they may get here and say, you know, we're gonna do it tomorrow.
Yeah.
Most of them are matter. I mean, they're set covered then. It's supplies, I guess, a number of years. I'm grabbing one of the people, grabbing the bag, and people are in there.
If you're looking at fingers, they come back in.
So they talk about you, now, the other way,
You know what they're doing.
how did this generally tell us?
Yeah, I put my hands in there.
Yeah, exactly.
And there's some good videos, a couple videos show
I did not lick my finger.
if there's no problem, the PRV that reduces it with a piston. So quick identification or plan B. Your driver did the FTC, there's times when you may not even ever pump. But the next thing you can do is looking for your next plan B. Is there a test header, where's the valve inside, or where's the riser, how much load you can take to get there, and go with the set water.
That building you
What's
go
up with that
to,
dealer?
building that,
Fancy over?
at the time when you have to pump in.
This,
It's
Skyer?
5 months, they pump it, or the backup power, the generator.
It's more, yeah, it's more expensive than.
There's gonna be no sprinkler or high pressure water on any, even the first floor, you're not gonna have that.
I mean, it still has some.
Again, it's the highest potential of what the usual parking garage.
Yeah, and the blueberries, protected, can't
Flow of
but
water.
sugar's going down on the left, it's not real.
Protect the rest of the parking garage. So there's no sprinklers on that floor either. You open the fire pump, kick on, and the pressure releasing valve works.
And you step back.
There's a crack in the line.
You know, it's shit. Yeah.
That's the stuff
Usually
you.
just straightforward now.
Yeah, the chicken eating cause is gonna be.
The key. They should talk early.
Yeah, I've got them in water, so it should be all right. You doing all right? You doing all right?
Your timer's about when you expect it. I don't know when, so I may be going to depending when the doctor's be available.
Sometimes.
You got no way anymore?
Yeah, in tracks, or just thinking about it.
So I'm working there, she's late.
I'm tired of it.
It's my 6 days.
Yeah.
No, that's Crowder.
Hey, Keith.
You were sitting here reading all the.
Oh, Beverly, that is Crowder, water. I just get something to do. This is $13.
I raised too much of this, we spent too much on it.
I think like 3 days.
ventilators or ventilators. He was in there.
What do we put on a patient assist for primary and secondary impression?
Should be none. If there's patient assist, or there should be no complaint.
They did, yeah, it said outside on the tag.
From the top of it compared to the bottom seat.
Yeah.
So
Yeah, I'll just
different
short
seats.
by,
Alright, thank you.
at some point, maybe it's gonna go at one point, take 3 beers by and just drop those off, so they got something where they get the other pair taken care of.
Yeah.
Making sure I didn't need any extra paperwork. or anything.
No, give them they do need, they won't need anything, but they do give them numbers.
Okay, thank you.
Real good.
Tom, I think you leveled up on your presentation abilities.
Absolutely. It seems like you might practice it.
It's fine, they need to hear it.
Looks like it's well rehearsed,
Well prepared.
well executed so far. I mean, you got 3 miles.
Pretty good. I'll give you the answers to the test.
There's a test.
There's the test.
That was the test. Light.
That's right.
You did a quick test.
Right, it is.
Oh, it's serious.
I'm recalling that test a lot.
Get into the remedial life class. Test might be a little bit easier. Was it
According to Dr. Tanner, but
did you put it in as a no patient with the system? That's not really a patient because they narrative. I would call them either subject or individual, whatever. But if you document no patient and then in your narrative you narrate yourself, then they will tear that up. Like if anything really happened and the lawyer were to come back and say, well,
I don't know who's got that.
you didn't do an assessment, you know, this, that, and the other. And here, you keep on referring to that as a patient. It was where they patient.
Very close.
And they don't say really weren't patient. Yeah, narrative is for a patient. So did you lie in there? That's all they need to take Clayton to.
Full-blown confirmation.
Yep.
And then I'll have a meltdown on the stand. Tom, that lawyer, it's real funny.
Don't bring that up right now.
It's a real familiar setting.
How dare you? Is it? It's not at all.
I remember there being a stand.
In here, it's not.
I remember being in the corner.
I don't remember any of it.
One full steam on that one.
Yeah.
Oh, it was awesome.
Wagging out's a real thing, man.
It's one of the best.
I just thought it was a good example. It was just a good example of what could happen if you're, ill prepared.
Time you gotta get your class under control.
You ready? We good to go?
Ready? Still recording?
Don't ask me,
Yeah,
I'm telling you. You're ready.
The type of system, we have automatic. So in an automatic system, the supply needed, the supply pressure needed and the water supply are already there and are provided when the valve opens. Automatic dry is only designed to have water in the system piping when in use. So we'll talk about this picture. We'll come back to this picture. Manual dry, this is exclusively provided by the fire department. So I believe one of our parking garages over on Maryland, right, is manual. Like it is a weird placard on there. I had a picture of one time that says it'll take this many gallons to charge the system and it should be charged about this amount of time. It's weird.
Is it the one on Rondelet, the Senting garage right
Yeah,
there?
through the alley.
Yeah.
Yeah, that one. So that's a manual drive. It's only gonna get what we provided. And then semi-automatic. This is what we usually have and call an automatic, but this, provides the needed pressure and water after activation of a control device or a fire pump. So automatic would be municipal supply. Semi-automatic is, the water is provided after a control is activated on the fire pump. This picture here is a dry pipe valve. You can see they're larger in nature. They look like that. Pressure on the bottom is the water being held back by air. Two different gauges. Sometimes these gauges will be different, which is confusing. So it's nice when they're the same gauge, but if you look at the number and where they register, to tell how these are tripped is that the air pressure is higher than the water pressure, which seems backwards. There's some type of scientific principle that says why that occurs. But in general, it takes less air to act on a small surface area to hold back a higher pressure of water. So if you see that, that's normal. The air pressure will be a little bit lower than the water pressure. There's a clapper valve in here so that when pressure on the air side drops, the water is forced in there and the clapper valve catches on a hook and stays in the open position. And then these gauges many times will just say air and water. And as you see, the air comes out the top, water comes out the bottom, and they both have different drains. So this is probably, there's drains on there. So we don't often have to mess with those, but sometimes if water's running in the area, you don't know why, it's good to know what these different parts are.
What do those two gauges do whenever there's water flowing?
When there's water, when there is water flowing, this valve is activated and water goes in the pipe, they should equalize, they should be the same. So whatever this is should be the same.
And then shutting that off, let's say we get a leak in a garage, how do we go about shutting this off?
So yeah, not pictured, there's probably a control valve down here which would provide just this riser.
Do you want to shut the pump off too if that's running?
Yes, very good question.
Thank you.
Risers and system design. So this is, understand this is pretty important. So each riser, as you can see here, the primary riser is rated or designed to put out 500 gallons per minute. And each additional riser will give the capacity of that system another 250 gallons per minute. So it's easy to explain by this picture. I love using pictures to explain. But so
real simple.
without a fire pump, this this hydrant is providing 189 pressure to the system, right? So it's going in. This little symbol here is a control valve. This little arrow. Sometimes these diagrams and pictures can be standardized, but this little check or this little arrow right here in line represents a check valve, and so or a backflow valve, so that the system and the head pressure can't flow back into the hydrant with the loss of pressure. And if you look at this, this section of pipe that goes up and comes over also has one, and that's a FDC. So we're going to get into it, and I'll repeat myself later, but an important thing to remember about the FDC is that it is piped into the discharge side past everything. Past the pump, past everything on the discharge side of the system. And there's no valve in there. There's no control valve. It cannot be shut. The only thing prevent water from coming out all the time is a check valve or a backflow valve, and that's what this is.
So when we have a high-rise fire, we hook up to the FDC, they say put a little pressure on that FDC. Does that just go in, or is there, does that just go into the loop of things?
Yeah.
Put that pressure on there?
Good question. We're gonna go into that a little deeper later, but no, you're either pumping against this check valve and there's a higher pressure on the discharge side, or you overcome the pressure and you provide the system. You don't supplement the system. You're either providing or you're not. And depending on, it could go back and forth, but just depending on what you're flowing in the building, what the residual pressure is, as lines open up and close, it could go back and forth. But that's why once you realize you're providing the system, you should probably make sure you're providing the system all the time. That way it's not going back. But see, as you go in here, we have 750 gallons per minute that's going through this pipe. The pressure is dropping from standard friction loss in the pipe. It's went from 189 to 136 while flowing this. So this riser is more remote, it's farther. So that's how they design these systems. So from the two most remote outlets, you have to flow 500 gallons per minute in all these buildings at a different residual pressure. So at 100 psi. So look, from the top one and then the floor below, we have 250 flowing from each one with a residual pressure of 100 psi. So that meets the demand. So we have another riser here. So the second riser only needs to be rated for a capacity of one valve being open. That's 250 gallons a minute. So that's flowing up here another 250 gallons a minute at a little bit higher pressure because it's not as remote. So that's how these systems are designed. The engineers do their complicated mathematics, but then once the fire pump in the system is accepted, they should go up to the two most remote outlets and flow 500 and at least have a residual pressure of 100 psi. And then each additional riser is 250. It's a pretty good picture to explain that, and it's important to know. Riser components, a riser control valve in the pump room can be a butterfly type valve, which is pictured here, just has an inline indication. If it's horizontal to the pipe, then it's closed. Or it can be an OS and Y, which is outside stem and yoke. So if you see the stem and it's out, then you can see it, the valve is open. If you can't see the stem, then it's closed. And again, these should be monitored for their position at the fire alarm panel. So if there's a fire, smoke alarm, certain floor, and then the IC or whoever's at the panel sees that a valve is closed, the investigation will go open it or go investigate why it's closed. The riser pressure gauge, these are pictured here. These are similar risers. There's one little difference. And then inspector test train. So yeah, we may use these if there's a leak or we're in the pump room and it's a combination system and we're not up on the floor, we can't find the sprinkler control valve, at that time, you can shut this valve and open up the test drain. That way you're going to drain it through a 2-inch line rather than whatever's leaking up through a sprinkler on the fire floor. But these are very similar pictures. So we got the supply here, the riser, butterfly control valves, a water flow switch. So it's just a little saddle valve with a flap, and these are designed so once it's activated for a certain amount of seconds, it just depends on how the system is set, it will alarm. But there also should be something that looks like this close to this valve, which sends the signal to the alarm panel that, hey, this valve's closed. And then, yeah, I talked about the drains and the pressure gauge. So, if we're fighting a high-rise fire, sprinklers are activated, the system's been charged. There's a number of valves or a number of gauges we can take a look at to figure out what our system demand pressure is or what should be being provided. This may be one. So, fire pump's kicked on, we measure that, and that may be close to what the system demand pressure is at that time. NFPA mandates that someone be sent to monitor and assess conditions in the pump room at a high-rise fire. So it's kind of the purpose of this class. There's a lot of components to understand and look at and monitor. So it's a mandate that somebody be down there to monitor that room and the components. And then, yeah, note the gauge on the pressures, including the riser gauge in the event of a fire. Standpipe valves. This is a class 1 valve, and it's a class 1 because it's a 2.5-inch connection. It's designed for fire department use, meaning that we can get heavy fire streams from the 2.5-inch discharge. And there's no hose in these with these valves. And these may be in a stairwell or in a cabinet. What makes it a class 1 is that it's a 2.5-inch discharge orifice. And the minimum flow from this valve is 250 gallons a minute. So, Bill Gustin, that's how these systems are designed. We talked about it, right? They're designed to flow 250 gallons per minute per valve. You many times will get more than that, but anything extra beyond 250 is, a bonus, all right? Class 2, these are 1.5-inch connection discharges. These are designed for occupant use or initial fire department operations and not, expected to be used for, extinguishing fires in a high rise. And they provide small fire streams. So a 1-inch hose, if this is alone, it's a class 2. So it means there's only 1.5-inch discharge in this cabinet, it's class 2. It is required to have a 1-inch hose, which is required to be inspected and in good condition if this is the only valve, and must have a restrictor to decrease flow when the residual pressure exceeds 100 psi. So these are generally in older buildings, and many times they're in hose cabinets. So in here may be some type of restricting device.
Attention all units on East Central Dispatch. East Central phone lines are back up. Attention all units on East Central Dispatch. East Central phone lines are back up. 10:45.
Yeah, so minimum flow from these is 100 gallons per minute, and they may have some restrictor here to limit the flowing PSI to 100 PSI. And this is a class 3. This is in a hose cabinet and it has both connections. It has an 1.5-inch connection with the hose attached and a 2.5-inch connection. Designed for both occupant use, initial fire department operations, and heavy streams from the 2.5. These are most often going to be found in hose cabinets in the hallway and not in a stairwell, but I mean, you could have this set up in a stairwell, but the older design is usually there in a hose cabinet. And there's a reason for that too, which we'll talk about. As you know, as we've gone along in time, the codes have changed to help us operate in a safer manner. And so we've gotten away from hose cabinets when we can, and these have been put into the stairwell. No reducer needed on the 1.5-inch connection if there is no hose present. So I think per the code or the jurisdiction, if there's a 2.5, they have let the hose go by the wayside. And I'll recall, calling on Captain Ted if that's correct. I know he took a
Repeat
class.
it, what'd you just say?
So if it is a class 3, true class 3 with a 2.5, they're no longer required to keep the hose there and inspected.
Only if the building's sprinkled.
Only if the building's sprinkled. Thank you. I knew there was a caveat in there. But if the hose is there, it needs to be inspected and up to date, right?
Correct.
Okay.
It's good for 5 years with new hose, and then it has to be inspected, tested, and maintained every 3 years thereafter.
But many of them, there's no hose in many of them.
Correct.
Okay. So, different setup, right? We have pre and post 1993 buildings. So the code changed dramatically for a number of reasons in 1993. So systems designed to flow 500 gallons per minute, like we talked about, from the 2 remote outlets with a residual pressure of 65 psi. That is pre-1993. In 1993, the code changed to require the same flow with 100 psi residual pressure.
What happened to make that change?
But and this chart here just kind of compares things here. So the minimum outlet pressure went from 65 to 100. Maximum outlet pressure was 100 psi. So there's more in the system, but we had those restricting devices to reduce it below 100 psi. Now it's only reduced below 175. So if you remember the numbers, 65, 100, and 175 psi, maybe 150. That's about all the numbers you need to know for the entire system. But okay, pressure reducing device reduces flowing pressure only. In the older systems, it was reduced beneath 175 to 100. And pressure reducing valves at both static and flowing pressures, they both had pressure reducing valves at 175 psi. We're going to talk more about that.
What changed that was the MGM fire in Las Vegas.
And the 1 Meridian plasma fire, which we're not here yet. Okay, but real quick before we get to that, we're going to talk about that fire. So pre-93 systems, we said operate with a residual pressure of 65 psi. So this was based upon fire departments operating, the code was built around this, using 100 feet of 2.5-inch hose with an 1.8-inch smoothbore tip, which we know if it's flowed correctly, flows 250 gallons a minute, right? That matches up with each valve, right? So each valve's rated to supply 250 gallons a minute. Anything greater than that is bonus. So with 100 feet of hose, the friction loss on that equals 65 psi. We know that's not how we operate now. We found safer ways. Connect to the floor below, stretch up, and then we talked about those distance of exit travel, right? And sprinkler buildings can be 200 feet. Non-sprinklered, it can be 130 feet, right? That's not very much hose. That's not enough hose. So that's where this math here just kind of shows what I just said. That's where the 65 psi was in the code. The 1 Meridian Plaza fire occurred in 1991. It was a 38-story Meridian bank. The fire occurred on the 22nd floor at 8:40 p.m. and burned for 19 hours. some contributing factors were there were improperly set PRVs to well below 60 psi. 3 firefighters were killed, and fire burned for 19 hours. This fire, the Meridian building fire in Philadelphia, was stopped by 7 sprinklers on the 30th floor. So it burned 8 floors over 19 hours and was finally stopped by 7 sprinklers. But it was estimated that the discharge from these sprinklers were 3 to 4 times the normal supplied amount that was available from the building, because the fire department had taken control. Our pumps can supply a greater capacity of water through that system to meet the demand. So there was a lot of water coming out of those sprinklers. It changed many standards. The fire attack was using 100 psi fog nozzle on 1 3/4 line with very, pressures reduced under 60 psi. They had no pressure. Very low psi due to improperly set PRVs. So these things do happen, and in studies and texts, people have found multiple PRVs set incorrectly in their building on annual inspections. So it's just a ticking time bomb if the fire were to occur before that problem is caused. Field adjustable. These PRVs were field adjustable, but a technician with the knowledge and the tools were assembled very late in the fire to increase the pressure. So why do we use 2.5 here in Clayton or in the county? Because we have older buildings before 93, newer buildings, and many of our older buildings still operate under 65 psi residual pressure. So using 2.5-inch hose, we don't have to play the guessing game or wait and grab smaller hose, which is more maneuverable.
On buildings before 1993, do you recommend the fire department immediately take over?
We're gonna get to that. If I don't answer.
Keep saying we're going to get to it.
What using 2.5-inch hose on every fire, even on modern buildings where we have a greater pressure required and provided, it standardizes our hose. Standardizes our hose throughout, our county and our mutual aid departments, and will help us overcome times of where we encounter lower pressure than we expect. So rather than grabbing 2 different size hose, 2-inch hose is become very popular for high rise because it's more maneuverable and can flow up to 250 gallons a minute or so. If we have older buildings where we may encounter lower pressure, standardizing our plan of attack and removing those variables, keeping the plan simple, we know what hose we're supposed to grab, 2.5-inch hose. And during this fire, it burned for a long time, 19 hours. The FDC supply hose was cut multiple times by falling glass. So, with extended fire, significant fire events, that's a real risk. So, there's things you can do, try to protect your hose with, whatever you can lay across it, close to the building. And what was your question, Brian?
So, buildings that are pre-1993 and you have a 65 psi residual pressure, do you recommend the fire department taking over the water supply immediately?
Yeah, so
to get the correct pressures?
in buildings that are, what he asked was in buildings that are pre-1993, if we should take over them sooner rather than later. So one thing that's good about NFPA 13E, you talked about it, it specifically addresses this in there. It's a question I had. So, well, the whole system is designed around the engine 1/8 tip, and so are the new ones. Hydraulic, 250 gallons a minute is what you get out of that tip. We're using 1.25 inches, which puts out 325 gallons. So once we hook up, we're asking for 325 75 gallons a minute. And we said, so far we've only talked about the risers, right? First, most remote riser is rated for 500 gallons per minute. Any additional is 250. So most buildings are going to be designed with a pump and a system that can provide 500 gallons per minute or 750 gallons per minute. So it's condition dependent. And what that would be is if you see a significant fire in an unsprinklered building, you got fire going out the windows or depending on conditions, how many hose lines you need up there. So if we hook up 2 of our setups, we're asking for 650 gallons a minute, right? Well, we've exceeded pumps that provide 500 gallons a minute. If it's a 750, we may be getting close, depending on the age of the system, the maintenance of the pump. We may be even close there. So in our older buildings, if we're using larger tip that are going to require larger flow, yeah, we may want to think about taking the building over sooner, because take the guessing game out of it. Is that building going to keep up? We're getting too close, or we definitely have outreached the capacity of that pump by putting in 2 lines with large flow tips into service. Yeah, then we would want to take over. So that's why we'll talk about how we're going to set that up. But that's a really good question.
Good question, Brian.
Good question. Thanks. Yeah, we'll talk more about it.
Can they retrofit those buildings now? Like in the 90s, if they're pre-93, they can retrofit those, correct? To get that up to post-93.
That's the question I had. Some may, many don't. I know many of our buildings,
They can though, like it's possible
they
without
could.
redoing all the piping.
you may get a good pump, but the piping has changed too. So without getting deep into the code, combination system require larger pipes than septic system, but they need that for flow. So really, you're going to get out of these buildings what they're designed to give them. And so the buildings are built to code back pre-93. They're kind of grandfathered in there. There's many buildings on Hanley Road that are 500 gallon per minute pumps. So in non-sprinkler, they're being retrofitted now, which is good, but they're not going to change. They're not going to change the supply rising. It'll be pretty labor intensive. Are they? That I don't know. PRVs and PRDs. So a pressure reducing valve. These are not used interchangeably. So a pressure reducing valve. This reduces static, not flowing, and residual pressure, which is flowing, at valves anywhere where the pressure exceeds 175 psi. And we'll get into how these work. A pressure restricting device. These are more commonly what was used on those older buildings. So reduce the residual pressure between 100 psi and 175 psi, not statically, only while flowing. So they restrict, they don't reduce down to nothing. That's pretty important, so I want to make sure everybody clear on that. Pressure reducing devices. Here's one picture here. You can see the only way this works is this arm connects with this piece of the device and limits the amount that it can open or unscrew. It is stored here, so it could be bent out of the way with pliers or with your Halligan if you did it in there, or any tool. Otherwise, if you have tools on you, you can probably just bend this out of the way. I think there's probably enough clearance you can bend it out of the way or break it. The problem is, when there is a broken hand wheel, it's probably because this has been bent, and it breaks the hand wheel. So, in some standpipe valves, they'll carry an extra hand wheel. That are just on. We're pretty good with our inspections. If there's a broken hand wheel, they better be replaced. But that's probably how those hand wheels are broken. Recognizing PRDs and PRDs, truck company doing their investigation and support work can identify these valves. Engine companies need to have the knowledge to overcome these and the tools to modify them when we're making a fire attack.
These are such a problem, why do they have them in the buildings?
They're built on the older design. So yeah, the code said it had to be reduced between 100 and 175. So that's how they did it. But they're made to be somewhat easily removed or altered for us. But if we need more pressure, that's
Does it keep pressure at the top of the fire loads in there, I guess?
because they assumed we were going to use less hose, so we needed less pressure, 65 psi. They didn't think we needed 100 or over 100. So
It's for all the head pressure. It's just restricting all that head pressure.
well, that would be in static. These don't reduce static pressure. So if a valve's open, as you shut a nozzle, everything equalizes. So in these older buildings, they would have PRVs if it was above 175, but they reduced it down between 100 and 175, assuming that we're using less hose. So it's only while flowing. These only restrict while flowing. And that's a good point, to bring up, is that these only reduce while flowing. That's why we can overcome them and just break them off and basically open up more of the hole so we can get more water pressure while flowing. So yeah, this one is scored here. This can be broken off. Our an Allen wrench can unscrew that Allen bolt and remove that pin. And here, this restricts it from coming out, and that pin can just simply be removed. So, did I answer your question?
Yeah, and as far as seeing this, that means the building is older than 1993.
Right. So some visual cues. Great point. To key in on our hose cabinets. This is an older design. So, like we said, they're assuming that we're going to attack from the fire floor, 100 feet of hose, to the fire. We operate from below, so those hose cabinets out in the hallway eat up even more of our hose, right? So, if we see these, they're in a hose cabinet. In general, they're most likely not going to be PRVs, especially if you see this, it's a PRD, but just restricting device. But yeah, most likely you'll see those in hose cabinets and not in the stairwell. Those are good visual cues that it's an older building. And that's something the truck company could communicate to command or over the radio, or just know your building, so you might need to take control of the pump earlier. There's a couple other restricting devices. This is a restricting plate. I believe it's just tack welded in there. You can bend it, break it out. And then this is a screw-on restricting plate that's adjustable that can just be totally removed with spanner wrenches, which may or may not be in the hose cabinet, but they're in our standpipe bag. Alright, pressure reducing valve. So it's important to understand the difference. The restricting device only restricts while flowing. The reducing valve reduces both static and flowing, and they're more of a problem for us. They're what we're more concerned with. So, like I said, reduces both during static and flowing conditions. The problems are they're factory set. You can't do anything about how they work sometimes. So a decrease in the supply into that valve will feel it on the other end.
And these are to keep pressure at the highest most point at what they need to be, correct?
Right, it will reduce them between 100 and 175. So if it's factory set, maybe it's 175. So we pump these buildings at 250 PSI. The way these work, we're going to talk about it, but they'll reduce it while flowing. Even when you shut down, it clamps close so that pressure doesn't build above 175. It's magic. Where's my magic? So a decrease in the supply of these valves will feel it on the other end. They can be improperly set, and you cannot pump into these. So a plan B that's been commonly taught is that you pump into the first floor riser and failure. If it is a PRV that operates like this, you cannot pump into it. So it's important to be able to identify these. So one way you can identify these is the bonnet. So most of them will have this bonnet on the top or a rim. That lets you know that we're dealing with a PRV. In general, they're just larger valves. There's more mechanics inside. They're just larger. Or it'll say right on there, it's a PRV. It said these can be factory set or field adjustable, meaning we can alter them, get more pressure. The manufacturer do not intend for us to control our pressure with these due to their design. So if they're 175 and we barely have it open on the bottom floor to get the pressure we need, this stem floats. It doesn't connect to this threaded stem. So as this goes up, the pressure pushes this up. So we barely have it open. Fluctuations in pressure on the supply side will push this up and down. So our stream will be all over the place. So they're not designed to throttle pressure with these. The internal actions reduce the pressure downstream in both static and flowing conditions, anywhere between 175 psi and 100 psi. So we know to operate our hose lines we need 90 psi, right? So if it's set very low, there may not be extra in there. It said some PRVs act as a check valve and can greatly reduce pressure and will not provide proportional increase when being pumped into. So the way they're designed is if you over pump these and they're factory set, you're not going to get any more out of them the way they work. Okay. So identification, how do we identify these? So they're larger in nature, they have a bonnet. This one has a rim, you can see it. This one doesn't, this one has a rim, it's a little bit larger. It's an indication that it's a PRV. The smooth stem versus the threaded stem, this will open all the way. This is not a PRV. This is smooth, which means it's floating. It floats in there, and this hole is how it works. We're talking about that. Or we'll just say it's a PRV, like it said right there, pressure reducing valve, and it has an arrow right here, so it lets you know that's the intended flow through this device. If you try to flow back through it, it will shut. And the reason it does that is that stem, that little hole in the stem is how it works. So as the water comes in, we unscrew the top, the water pressure pushes this plunger up, space is increased here, pushes this plunger up and fills this cavity. The pressure goes in through the stem, comes up into this area up in the bonnet, and it provides pressure down so that as pressure builds, if it builds to 175, it shuts. And that's how it reduces it when the nozzle's closed. So the pressure builds, 160, 170, 175, pressure builds here, it shuts it. So that way you don't have 250 psi at your nozzle tip when you open it, or in the hose when it's not working. So because it works like that, if we try to backflow through here, it shuts.
And these won't be on every floor, it'll be on every other, or wherever they deem necessary. So if you did need to hook up, you would just go to
anywhere
the next
in a system
floor
that has 175 psi, they'll be present. So about 15 floors. Well, anything above 15 floors, you can start adding those PRVs on the bottom if you think about it. Because 15 times 5, 75 plus 100, what we need is 175. So, and those numbers mean like we have 5 psi of elevation losses per floor. So once you get up to 15 floors, that's 75 psi required just to get it up about 15 floors. So you had 100 for what we need to operate our hose line. So anything kind of in general, that's my rule of thumb. Above 15 floors, you're gonna have a PRV on file. And that's the same for pre-1993 buildings. Those will have it too. Anything above 15 floors, you know, or they may not because they may be on a 65. So identification is key. If it's a smooth stem, it's PRV. Can't backflow through it. Here's a picture of another one. So obviously it says it's much larger. This is a field adjustable PRV. So it's this long stem, the nut here. So we talked about how that works. It goes up through the stem and is allowed to push down. So these are not connected right here. The tension on this spring, you know, determines the pressure reducing capabilities of this valve. So to overcome it, you take a pipe wrench, screw this off, and a deep 1.16" socket. You can compress this spring. You actually tighten it down, and you get more pressure. So I don't know what type of, you know, the one Meridian Plaza Fire probably had older PRVs, but they had PRVs that they couldn't adjust. But this is a common one that you can adjust. You just need to have the right tools. So here's a picture of him doing that. And to do this, you would start your flow, hook up your hose, open it up, and then you would tighten it down to the pressure you need. Yeah, so you need a large pipe wrench and a deep 1 1/16" deep socket. Here's a picture here. So what they've done here is the same type of valve we just looked at. The tools to adjust this valve are located in the fire command room or the fire pump room. And they have them hanging here. So they have a pipe wrench, they have 3, and then 3 sockets. So that's one way to overcome it. You can have the building supply those and keep them on hand. Or we're going to go over the 2 most common types. Just adding 2 tools to our toolbox to take care of it in our fire truck. We don't need to carry these around every fire alarm call we go, or put in our standpipe bag. Because 1, may not be a problem, and 2, all the valves are different. But we do have those in Clayton.
Hey Tommy,
Yes.
the deep well socket, is that dictated by code? Or is that just a manufacturer's choice?
It's the common, you know, I don't know, but I think it is standardized because I've seen it in multiple places that.
Yeah, I was curious because, you know, sort of like elevator keys where, you know, if we get on a scene and need it, are we going to have to figure out the size of the deep well socket we need, or is it dictated by code?
Right, and through pre-planning, that's what we could do. We could, you know, find out about the valves, check them, but I believe those are kind of standardized or the most popular ones.
Right, and we could, in theory, ask the fire marshal to amend the code to make them, keep them in the fire control room?
Right. Yep, they could do that, or we can add a couple sets to the fire truck, assuming we have the fire truck with us all the time. But I think those are both better options than carrying around all this what-if equipment in our everyday standby. Here's another type. These are similar in design and the way they work, but this one is called a Giacomini, and it's a pressure reducing valve. Has a large wheel on top. We have one at the firehouse somewhere. I've seen it float around. So it takes a lot of pressure just to open it under normal circumstances, like 75 pounds of pressure to turn that wheel. But you see here it's larger in nature, so you know it's probably PRV. It's got a collar here and a protective collar here. These are the same. This is a smaller wheel. These are more easily open. There's an Allen wrench here. You could remove this plastic cap, or you just break it. But they both have a little hole on this collar where you could use a 3/8" rod, steel rod, to compress the spring inside and get more pressure out of it. So again, there's another picture of these. these rods stored in a command room where you can put a few on your apparatus. And then again, this is just a diagram that shows how it works. We already kind of explained it. As the pressure comes in here, on the downhill side, it goes through the stem up into this area and pushes down on the plunger. And it just explains what we already talked about of how it reduces the static pressure. So the other thing this goes on to say is that these PRVs can be on our standpipe outlets, but they're also in sprinkler connections. So if you're not feeding the building the correct supply, the sprinklers aren't getting it either. Which is why you should always pump the roof. If you just pump the fire floor, you could have PRVs in your sprinkler system or on your standpipe, so you always pump the fire floor. And that's also in NFPA 13E. But there's a few really good reasons to pump the fire floor all the time. Yeah, so you can see these on sprinkler lines as well. Hang on one second, try to get a video play. And we're gonna take a little break.
You want more coffee?
Tom, you want to pause this while you figure that out?
Yeah, why don't you guys take a 2-minute break and I'll figure it out.
Real quick before
Yeah,
you,
you're good.
Hang on,
Shut that
I don't know
off.
how to pause this.
The red button. The red button. On top.